Okay, everybody. So what we're going to be looking at today is going to be solutions to the practice exam 3. So keep in mind this is only going to cover just a couple of sections in the book, and the exam's going to only have 5 questions. It's going to be very similar to these practice problems that we go over today. So basically here's what you're going to get. You're going to get a few problems from section 5.4, which is recursive algorithms like merge sort and that kind of thing. And then you're going to have a couple problems from, I think it's section 11.2, which is finite state machines. Now, this doesn't really need to be a test. It could have been an assignment. I'm making it a test because, number one, I think it'll help your grades to have test because it's worth more. And number two, I need you to answer one of these questions for the SLO assessment for the class. So if I just made it like a regular homework, some people might skip it. So this should take care of that issue. Anyway, let's go ahead and get going. So the first few questions are on section 5.4. Like I said, we do go over them in the notes and the lecture on this topic, but we'll go over them right now too. All right. So number one from the practice problems is that we want to use merge sort to sort the array. Let's see here. 1, 5, 6, 7, 8, 2, 3, 4, 9, 10. Okay. And that's it. You just need to write it out basically the way that we write it in the notes and in the book. So yeah, let's do it. So you start out, the way merge sort starts out is you start out with the original array. So I'm just going to copy it, 1, 5, 6, 7, 8, 2, 3, 4, 9, 10. Now this example will turn out to be a little bit weird, maybe compared to some examples. Um, and that's going to be because of the way that like 1, 5, 6, 7, 8 is all in order. And then 2, 3, 4, 9, 10 is all in order. So like the left hand half and the right hand half are individually sorted, which makes this work a little weird. But it is what it is. So let's go. So the way merge sort works is it starts out by splitting your array into two halves. So 1, 5, 6, 7, 8. And then over here, 2, 3, 4, 9, 10. And then it keeps splitting those in half until every uh, sub array has one thing in it. So we keep going. Now, I believe that the merge sort as it's listed in our book, that was supposed to be a straight line. Merge sort as it's done in our book um, uses the floor of half of the elements in order to make the split. So what that means is if you split an odd number, then the second half should have one extra thing in it, right? So 5 doesn't divide evenly, so 2 over on the left, 3 on the right. Just because of, again, the way that our specific algorithm will do it. If you do it the other way, 3 and then 2, it doesn't really matter. That's still a merge sort. It's just not exactly the way the book wrote it. Okay. So then from there, you split each of those 4 arrays into 2 arrays. So 1, 5. Over here, we got, again, 3 doesn't divide evenly. So we have to go 1 and 2. But the 1 is on the left, the 2 is on the right. All right, almost done here. Okay, Now, there's still a couple left that have two things in it, right? So like we got right here, 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 here. Those are all done. But there's two groups that still have elements in them, more than one element in them. And so we still have to split those like this. Okay, so at this point, that's not what I wanted. At this point, everything's been sorted into one element list. So this is where you start putting the list back together. So this is kind of like the midpoint. So now what you do is you start putting the list back together. So that means we're going to start merging things. So we're going to merge that 7 and 8 into a 7, 8. Now when you merge these, you merge them in order. So like the 7 and the 8 are both being regarded as one element lists that are in order. And then the merge algorithm combines two in order lists into an in order list. So it will combine the 7 and 8 into 7, 8, not 8, 7, right? There's no risk of it doing 8, 7 because it only will combine them in a fashion that keeps them sorted. Same with the 9, 10. Okay. Now, the reason we only did those two is because at this level, that's all there is. So you can kind of think of like the 1, 5, 6 and the 2, 3, 4 as being carried down here. If you want to, right? Like you can kind of just bring them down here like this, right? You don't have to write them that way, but maybe it'll help you see what's going on. Okay. And then from there, we just keep merging everything the way that we were doing it. So like you merged the 1 and the 5, we're just going backwards now, putting that together. Then we'll merge the 6 and the 7 and 8. We'll merge the 2 and 3. We'll merge the 4 and the 9 and the 10. And then we merge each of those. And again, it will happen in order. So 1, 5, 6, 7, 8. 2, 3, 4, 9, 10. Now it feels like we're not doing anything because 1, 5, 6, 7, 8 is already in order here. And that's because it started out in order here, way at the top. If it was out of order, we would be doing something now that you would see. So it's just kind of because of the specific array that we started with that we're not really seeing much going on until this last step, right? Because we've got 1, 5, 6, 7, 8, 2, 3, 4, 9, 10. They're going to be merged in order. So you're going to get the 1 from the first set, the 2, the 3, the 4 from the second one, then back over here to get the 5, 6, 7, 8, and then the 9 and the 10 from over here. So it will merge them in order. And, then you're done. And that's a merge sort. So you can see this done in the book, and you can see this done in the notes. Also, you can see it done right here. And that's how you write out a merge sort. So what we're going to do now is we're going to do problem 2. Problem 2 is pretty much the same as problem 1. It's just that we're going to be sorting letters instead of numbers. So we're going to sort B, D, A, F, G, H, Z, P, O, K. And we're going to sort that into alphabetical order. This one doesn't look like it's got the same kind of ordering thing going on as the previous one. So we'll see more going on with this one. How many things do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 again. Okay. So just like before, you split it into 2. B, D, A, F, G, H, Z, P, O, K. You'd split that into 2. B, D. Oops. A, F, G. over here, we're going to have HZ, EOK. Split each of these. B, D. I feel like I shouldn't have put these little brackets around everything because taking a long time to write just because of that. But I feel like it does a better job of keeping stuff separate. Okay. All right. So just like before, we've got most of this split into one element list, but the two at the end here, the F and the G. Whoa, I wrote that wrong. Hold on. Let me fix that. The F and the G need to be split. And here the O and the K need to be split. Once everything's kind of split, that's kind of like your middle. Not kind of your middle, it's just that's the middle. And now we start merging stuff back together. So just like before, we're going to start merging these first. So now we got an O and a K, and it's going to put those in order because that's how the merge algorithm works. Is when it merges a list, it will put them in order as it goes. So O and K, it'll write KO. Okay, so we've got those. Now the ones that we haven't done yet, the BDA, the one element lists, need to be kind of carried down. Again, you don't have to carry them down the way I am. Just maybe, I think, makes it a little easier to see. Okay. And now we start merging everything. So two at a time, you got B and the D, that'll be DD, BD. You got the AFG, that'll be AFG. You got the H and the Z, that will be HZ. And you got the PKO, which will go KOP, right? It will put them in order. Then we're gonna pair those off and merge these. And again, puts them in order. So we're gonna have A from here, then B, then D, then F, then G. So A, B, D, F, G. And here it will merge them and put them in order. So we'll get K. Whoa, no, we won't. H, K, O, P, Z. And then we will merge all of them into one list. Alphabet's hard, so let's go through this. So let's see. We got an A, so that must be first. Then we got a B. Oops. So that must be second. We got a D. That means must be next. F. G. Then we got, let's see, H, K, O, P, Z. Okay. Oh, that's interesting. So the way these were set up, these were from the book. So it looks like the way they were set up was so that in that first example that we did, when we merged them, there was no kind of reordering going on until the last step. And on the second example that we did, there was reordering done various places here, like here and here. No, here and up here. But in the last step, it's actually just the entire first list and then the entire second list in order. So interesting. Anyway, but that was a merge sort and we did it. So section 5.4, there you go. Okay, so that's it. So also in section 5.4, we have a recursive algorithm. So let me just kind of erase that. So just recursive algorithms. So you're going to have one or two of these on the actual test, just like you have here. Now, the thing about a recursive algorithm is, remember, it's just going to be like basically a function that calls itself. in this case, an algorithm that calls itself, right? Uh, a function that calls itself. That's not quite what it is, but it's kind of like an algorithm whose definition relies on performing the same procedure on a smaller subset kind of thing. Um, but a function that calls itself is kind of the easiest way to think of it. So let's think of it that way. Okay. Now, let's get going. So let's see here. Devise an algorithm for the sum of A1, A2, A3, dot, 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 AN. Okay. And so on all of these problems, there's going to be a very, very simple idea. So you're trying to do the sum, in this case, it's a sum of a bunch of numbers, right? And basically the way you want to think of it is like this. The sum, if you have just the sum of a single number, the sum of a single number is just going to be the number, right? Of course it will, right? That's obvious. So this is kind of like number one thing I want you to think of. Number two thing I want you to think of. The sum of a single number is itself. If you have the sum of a lot of numbers like A1, A2, A3, dot, 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 up to AN, you can think of that as just being AN plus the sum of all of the other numbers, right? So you can actually write the sum of n numbers as the sum of n minus one numbers, but then just plus one extra number, right? And that's what all of these recursive algorithms are going to have in common, is the same kind of idea, where there's kind of like, how do you sum one thing, and then how do you sum n things? And then you just write an algorithm, which is, you can actually write MATLAB code if you're more comfortable with that. But the algorithm, is like the book pseudocode, which is not quite, not quite actual code. So let's try to write this. I will write it first the way the book does, and then maybe I'll just write it in MATLAB code so you can make more sense of it or something. So here's how the book would do it. So the book would go procedure, and then they would give it a name, sum, and then they would tell you what goes in it. And they would even tell you that those were numbers or something, real numbers. And then in the procedure, they give you the rules here. Okay. And basically, those two things that we put here, that makes up the entire algorithm. So you would just say, if for our procedure here, if n is 1, right? Because we're going from A1 to AN. So if n is 1, there's only one number. Then you just want to return A1, right? So if you say, what's the sum of A1? Answer A1. But if you have more than one things, more than one number, so else, then how would you do it? Well, in that case, what you would want to return, what you would want to return is exactly what we got right here, right? Just this kind of thing. So you want to actually take the AN and add it to the sum of all of the other numbers. And so this will stop at AN minus 1 because we just split the AN over here. Okay? And that's actually the entire thing, because remember, the book pseudocode does not bother with, like, they don't end if statements. They don't end else statements, and so on. So that's it. That would be what you do. And really, it's just essentially just listing these in a function, basically, these two facts. Now, what would it look like in MATLAB? Um, you know, in MATLAB, the code would be like this. It would be function. Actually, you need a return variable. So you would say like s equals sum, and maybe I'll call it like r sum. And remember how we normally do this, right? Is in MATLAB, you would just have a variable like that we call a that actually has uh, in numbers in it, right? That'd be a vector, vector a. So you started out that way, and then basically you would have what we have written, but in MATLAB. So you would say if, oh, actually we can't do that because we need an in, right? So you'd have to go in equals length a, semicolon, and then you would do if in equals 1. You wouldn't do a return, you would just say s equals r sub a. S is the return variable. Oh, no. Sorry. Terrible things happen. Right? If n equals 1, you want to return just the first number, which is a1. Else, s should be a n, the last number, plus our sum. And what you'd have to do here is remember, basically take the nth element away. And there's various ways to do it. Here's how I'll do it. A1 to n minus 1, semicolon, end. And you can end the function as well if you so choose. Yeah, so that's what it would be in MATLAB. So you could write code if it's more comfortable for you, or you can just write pseudocode like I did the first time. And both of those would be a recursive sum algorithm. Now, recursive algorithms are slow generally, and you wouldn't want to use them, but they're easy to write. And that's what we're doing, is we're writing them. Okay, so yeah, so let's get started on the next one. So number 4, it's going to be the same exact idea. Devise a recursive algorithm for x to the n, and x is a number, and n is going to be non-negative integer. Non-negative integer. So non-negative means it can be 0. 0 is allowed. Why can't I write negative? What? Non-negative integer. Okay, that's why. Because I was trying to spell negative in the middle of spelling integer. That's why. Okay, so we're going to compute x to the n. And again, the idea is going to be the same way that we had for the previous one, right? The idea is the smallest, if you have like x to the 0, right? That's just going to be 1. And I don't know why I'm writing number 1, number 2, just to keep it separate from this kind of numbering. If you have a bigger power, x to the n, what you would do is you would say, well, it's going to be x times x to the n minus 1, right? You can split up a power that way because you add exponents, right? So x to the 1 and x to the n minus 1 add up to n. Oops, not what I was trying to delete. So if you know those two basic mathematical facts, then this is going to be really easy to write. So procedure. How are we going to call this? I guess we're going to call this pow for power, and you're going to pass in an x, and you're going to pass in an n. So x to the n. How will you do it? Well, you will say if n is 0, you should return 1. Otherwise, and so we're assuming that you don't pass in like a negative number or something. So we're not doing any error checking, but we're assuming n is actually 0, 1, 2, 3, 4, 5 integers. So if n is 0, return 1. Otherwise, you want to return x. I guess we're not writing code, so I can write x times pow x in minus 1. We don't need a semicolon. There you go, right? So it's recursive because the pow function is going to call the pow function, and that's all there is to it. Just like before, the Matlab code would be super easy to write. You would simply go function, I don't know. What's the output? I guess S. We'll use S again. I don't know why. Pow x in. And then we don't need a length because there's no vectors here. So you would just jump right into if x equals 0, S is 1, else S equals pow. Actually, x times pow x in minus 1, semicolon, end. Just like that. Okay, so whether you write it in Matlab or you write it just as pseudocode, it doesn't matter. Both of those are acceptable. Super easy, super easy. And I fully expect that, you haven't done these problems before. That's why I'm making you do them now. So probably you didn't know how to do these coming into this, but you should be able to figure it out on the test. And you can come to office hours if you need help. All right. Another one, we're going to do a algorithm for the max of a list of numbers A1, A2, A3. Up what? Up to AN, sorry. Algorithm. So this is actually the hardest one to do, by the way, because if we're thinking about it the way we did before, then what you have is, if you have the max of just A1, of course, that's very easy to do. That's just A1. But if you have the max of A1 up to AN, what you're going to do is you're going to say, well, okay, well, you can split off the AN and you can do the max of A1 ... up to AN minus 1. And that's what looks like what we did up here, right? Like, right, you split one of them away and you have N minus 1. You split one of them away and you have the rest of them here in the sum. But the problem with this is your maximum could be in here, or your maximum could be here. So you actually have to figure out which is bigger, this or this. So you actually have to figure out which is bigger. And that's what gets returned. All right. So this is actually slightly more complicated than the previous two examples. So if we're doing pseudocode, again, procedure, let's just call it max, A1, AN. Like before, if you've got just one thing, so if N is 1, then we're simply going to return A1 because that's going to be the maximum. It's the only thing in the list. Otherwise, we've got to figure out which of these two things is bigger, the AN or the maximum of the others. And so really what we're going to need to do is calculate this so we can refer to it, so we don't have to recalculate it more than once. So temporarily, let's calculate this max. So you go like m equals max a1 up to a n minus 1. All right. So we're going to calculate the maximum of a fewer number of elements. We take the a n off. And then what you're going to do is you're going to say, well, if a n is bigger than that maximum that we just calculated, then you want to return a n. Otherwise, you want to return the m, right? So basically, you calculate the maximum with the ending a n not there, and then you can just say, well, what's bigger, the last element or the maximum of the others? And whichever one's bigger, that's the one that gets returned. So like I said, a little bit more complicated than the others, but there you go. And of course, you can do it in Matlab too. Might as well. Function. I'm going to call it Rmax, just because if you actually implemented this, there's already going to be a maximum built into Matlab. So let's say m equals Rmax a. And then you're going to need to know how many things there are. So you have to do length a to get the number of elements. And then you can do your if statement. If n is 1, we're not going to return a1. You're just going to say m equals a1. Otherwise, then we got to do this business. So otherwise, you would want m to be the maximum, I guess Rmax of a1 to n minus 1, semicolon. And then we do our if statement. If a n greater than m, then m is going to equal a n. Else, actually, we don't even need to do an else because we already have, we don't need to do an else because if a n is greater than m, then we should make m to be equal to a n. But if m is bigger than a n, then m is already the max. And we're returning m according to this. So you don't need to actually say like return m like you do here. We don't need to do anything because m is already storing the correct thing. So you can just end that if statement there, and then we would end that if statement, and then we would end the function. And that would be a recursive maximum in MATLAB. Okay, so yeah, so those are recursive algorithms. You're going to get 2. They'll be like the ones that are here. They won't be super hard. Okay, so that's it kind of for those recursive stuff. Then you're going to get a couple of questions about finite state machines. So let's talk about those. So number 6, finite state machines. So the way these work is that there's a kind of a one-to-one correspondence between the state machine table and the state machine diagram. And so that's what we're talking about here. So I have to draw this table. So got S0, S1, S2, S3. These are my states. And then this state machine has inputs of 0 and 1. And you have to write those twice. Okay. And the reason you have to write those twice is because essentially the table has 2 parts. So this is where you're going to put your next states. And this is where you put your outputs. So we've got two kind of halves of the table here. So this table, I'm just copying it from the problem. So we got S0, or sorry, S1, S0, S2, S0, S0, S3, S1, S2. And then here we got 0, 0, 1, 1, 0, 1, 1, 0. Okay, so there's my table for this state machine. So let's see here. A. So in part A, they tell you a current state. They say current state is S1. And they tell you the input. Input is 1. And then what they want is they want the next state, and they want the output. Okay. Now this is actually very easy to do. All you got to do is say, like, what's the current state? The current state is S1, right? It says it right here. So where's the current state? So the current state S1 is right here. Okay. So that tells you that you're in this row. And then you've got your input is 1. So the input of 1 is right here. Also, it's right here. So you're like that and like that. Okay, so where do they cross? Well, they cross here. Oops, that's not what I wanted. They cross here and then they cross here. So those are your answers. Your next state is going to be right here, the S0. And your output is going to be right here, the 1. And that's how you do that. So really kind of easy peasy once you know what you're doing there. Like there's a lot of writing, but I mean, there's a lot of numbers and stuff in the table, but it's not actually hard. All right, next one. So it's the same type of thing. So it says current state, S3. And the input is 0. And we want, again, the next state. And we want to know the output. So we just like redo what we did here. Exactly the same thing. So we got the current state is S3, so that's here. And the current input is 0, so that's here. And then you just read off the intersection for your next state and for your output. So we got S1 and 1. Okay, so that's all you got to do for that table there. Now, the next part, I guess, is a little bit harder. We're going to be drawing a state diagram. So a state diagram represents the same information as the table, but it does it in a graphical form. All right, so the way this works, I'm going to have to copy paste that table probably. But so the way, actually, let me do that. Duplicate. Put it right here. Okay, so the way the state diagram works is you put your states. So our possible states are S0, S1, S2, S3, just as circles. I don't know why I wrote it's 1 first. All right, good enough. And then basically what you've got going on here is every single input and current state gives you an output. So like, let me show you a thing. So if your current state is S0 and your input is 0, then this is your next state. And if your input is 0, then this is your output. So the part that I highlighted there, what this is saying, the fact that S0 and 0 intersects at S1 says draw an arrow from S0 to S1. From S0 to S1. Now, what was the input? The input was 0 there, right? So that's the first number you write up there. And then what's the output? Well, the output is right here. It's 0. So that's the second number you write there. So like this is the input and this is the output. Okay. And so the part that I highlighted there, that is going to give me that like this one piece. So you could say, well, what if the input was 1 instead of 0, right? If that was the case, then this would have been your next state and this would have been your output. So for the green here, let me erase. Right, so for the second one there, what you've got is if you're in S0 and the input is 1, the output, sorry, not the output, the next state is S0. So from S0 to S0, and you just draw that like this, S0 to S0. And what was the input that did it? 1. And then what is the output? 0. Like that. So basically every row is going to give you 2 arrows on here. So like this one right here. This one right here. So let me erase. So like if you got, nope, not what I wanted. Right? That would be for S1 with an input of 0. This as well. So what are we going to get? So this one tells you like S1, with an input of 0, you go S1 to S2. So S1 to S2 when the input is 0 and the output is right here is 1. Then you do this one. So S1 to S0 when the input is 1. So S1 to S0. So S1 to S0. That was when the input is 1. And then the output is also 1. And you just keep doing this. So let me kind of clear off this table here. See if we can go a little faster. So this one right here. This is S2 to S0, right? S2 to S0 when the input is 0. S2 to S0 when the input is 0. So S2 to S0 when the input is 0. And what would the output be? Well, you'd have to look here, right? Because it would be like this. So the output is also 0, I see. Okay. Now this right here is S2 to S3. So S2 to S3. And that was if the input was 1. And then the output would also be 1. Like that. And then we're in our last row now. So last row. So we got S3 to S1. And that's if the input is 0. And also the output will be 1. All right, last one. S3 to S2. S3 to S2. That was if the input is 1. And the output looks like it will be 0. So there you go. So that's how you draw the state diagram. Again, you can also look in the notes for section 5.4 for drawing a state diagram. Okay, that's probably the hardest problem like on here is drawing the state diagram. All right, last question. This problem, I wrote 5 here. No, that's 6. Okay, that's right. Last problem, 7. Whoa. Okay, so this is going to be the other way around compared to the previous problem. So this problem, they give us a state diagram instead. Not drawing it very carefully here. We just need to be able to see which direction the arrows go. If you can tell which directions the arrows go, then we're fine. And they also say start, but we don't actually really care about that. Okay, so they give us this state diagram, and then they ask us essentially the same type of questions. And they're not any harder to answer over here. Well, maybe a little. So part A says if the current state is S1 and the input is 1, then what is the next state and what is the output? So just the same type of question as the previous one. All right, so how do you do it from the state diagram? Probably easier than the table. So your current state is S1, so that's here. And your current input is 1. So that means you're going to be looking at arrows that leave S1. So, right, because you're going from S1 to another state. So there's 2 arrows that leave this circle. There's this one right here from S1 to S0, but that's for an input of 0, right? That's what this first number is. So S1 to S0 when input 0. The other arrow that leaves S1 is this arrow. So S1 to S3, and that's when the input is 1. So you would need to notice this number here. That's the input of 1. So once you can find the S1 and the input of 1, then you can write your answer, because your answer is going to say that we go to state 3, right? S1 to S3. And what is our output? Our output is the other number right here, 0. We get a different color here, right? So that output is that output. Okay, and that's how these go. So let's do B. It's going to be the same type. Current state input, next state, and output. All right, so what's the current state? Oh, that's given. So current state S3, input is 0. Okay, so again, I'm not going to highlight this one. We'll just do it visually here. So current state is S3, so we're here. And the input is 0. So there's going to be more than one arrow leaves S3. This one, but S3 to S2 has an input of 1. And S3 to S1 has an input of 0. So this is the correct one. So this is the arrow that we're looking at. So if this is the arrow that we're looking at, then the next state is going to be S3 to S1. So S1, and the input was 0, and the output is 1. Like so. Okay. So that's not really, that's maybe a little harder than the previous one, maybe easier. I don't know. Depends on your point of view. Uh, what do we got to do now? We got to draw a state table for the diagram because they're interchangeable pieces of information here. So what do we got? So we need one of these tables. Okay, so we got a blank table here. We're going to have to refer to this, so let me cut it out. Here it is. Okay, so let's figure out the table. So again, uh, every arrow is going to be something we look at, right? So like starting at S0, right? Because we're starting at S0. So here is, oh, I kind of dragged that off the page there. I'm gonna have to write that number in. That arrow there is 1, 0. Okay. Um, okay. So like if you want to figure out like this spot right here, right? Then what you would be looking for is a current state of S0 and an input of 1. Sorry, input of 0. So if you're currently at S0 and your input is 0, then you must be looking at um, this arrow. So where will that take you? It'll take you from S0 to S1. So this is S1. Also, it's not just that because, sorry, hold on, I'm trying to get a highlighter color. Because the output is 1 there and the input is 0. So that's also this part of the table. Okay. Now, then what you got to do is say, well, what other arrow comes out of here? Like if you want this one right here, where is this going to be on your picture? Well, that's still going to be S0, right? So if we're starting at S0 and the input is 1, that's right here. So that's going to take you this way. So with the input of 1, your next state is going to be S2, and your output is going to be 0, it looks like. Okay, so that's how these go. So let's keep going here. So you're at, where are we now? So we're at S1. So S1 is here. So S1 with an input of 0. Again, you're looking for arrows leaving S1. So this arrow leaves S1, right? Input 0. This arrow leaves S1, input 1. So this is the one we want. S1 to S0, input 0. S1 to S0 with an input of 0. What's the output? Well, S1 to S0, input 0, output 1. So we put that 1 right here. Okay. Next one, we got S1 to S3 with an input of 1. So S1 to S3, there. The input was 1, the output was 0. Now we're doing S2. So S2 is here. So 2 arrows leave S2. this one, this one. So S2 to S3 with input 0. S2 to S3. S2 to S3. Input 0, output 0. Then you've got S2 to S0, input 1. So S2 to S0. Input 0, output 0. Last one, S3. So S3, we got S3 to S2 and S3 to S1. So S3 to S1 is going to be input 0. S3, S1. S3 to S1, input 0, output 1. Then we got last one. Okay, S3 to S2, input 1. S3 to S2. So there's S3 to S2, input 1, output 1. Okay, so we made it. That's the table that we're looking at. So you can always go back and forth between any diagram to a table or from a table to a diagram because they display the exact same information in two different ways. So yeah, that is what you may have to do on the exam. So probably what you're going to look at on the exam is something like 6, something like 7, maybe with one, maybe not with 3 parts, maybe only 2 parts each or something. A couple problems like problems 3 through 5, like devise a recursive algorithm, but probably only 2 of them, not 3 of them. And maybe some kind of merge sorting stuff. So a total of like 5 problems. And if you have a pretty good idea what you're doing, you can probably crank it out in an hour or two, maybe even less. So yeah, that will be available probably midway through the day on Wednesday, and you'll have until Saturday to do it. I said Friday, I think, in the announcement, but I know that some people work and they need Saturday to finish this up. So we'll make it due officially on Saturday. So yeah, talk to you guys later.